Find the inflection points of f of x is equal to 1/2 x to the fourth plus 2x to the third. So the first thing we're going to need to try to do is find the second derivative and then use it to find places where concavity can change. So in this case, f prime of x is going to be equal to, we're going to have 2x to the third plus 6x squared, and f double prime of x is going to be 6x squared plus 12x. Now, we're dealing with a polynomial function. It's going to be continuous and differentiable everywhere, so we're not going to get any places where we can change inflection either from the domain of this function or from where its second derivative is not defined. But the second derivative does have, looks like 2 zeros. We can consider 0 is equal to x squared plus 12x. If we divide both sides by 6 and then factor out the x, we can write that as 0 is equal to x times x plus 2. And we see that we will get zeros when x is negative 2 or 0. We'll use those values to create a sign chart. Negative 2 and 0. We'll test the second derivative in each of the intervals. So I'm going to choose f double prime of negative 3, f double prime of negative 1, and f double prime of positive 1. Plugging into the second derivative, I'm going to get 9 times 6 here, that's 54. I'm going to get a negative 36, this should be plus, concave up. If I plug negative 1 in, I'm going to get 6 minus 12, that's negative, concave down. And if I plug 1 in, everything's positive, so we're back to concave up. So I have two different places where concavity changes. Both numbers are numbers in the domain of the original function. So we're going to have two inflection points, or points of inflection if you prefer. The first is going to start with the coordinate negative 2. So we're going to need to plug negative 2 into the original function to find the y value that goes with it. So we're going to be interested in 1/2 times negative 2 to the fourth power plus 2 times negative 2 to the third power. Do that on my calculator here. Make sure I've got it typed in right. 0.5 times negative 2 to the fourth power plus 2 times negative 2 to the third power. I get negative 8. And the other one's going to have a 0. Well, when we plug that in, pretty clear we're going to have 0. So two inflection points, two places where concavity changes, negative 2, negative 8, and 0, 0. As always, I encourage you to graph this on your calculator and make sure that the picture has the same qualities that we found using our analysis here.